In this video, we are going to look into how does all these factors affecting the rate of reaction is explained by the collision theory. Now, here's the thing, okay? Whatever you had seen in the factors affecting the rate of reaction, all of them generally can be affected or not really affected by, explained by the collision theory. Now, for example, let's say let's start with the first factor. Okay, so the factors affecting the rate of reaction. Okay, the rate of reaction. We know that the first one, okay, the first one that we can actually write is the size of reactants. Yeah, so let's start with the easy one first, huh? Now, the logic that we know that is smaller reactants, they can react faster. So let's say, okay, a smaller size of the reactant is going down, then it means that the surface area of the reactant is going up. Now, what is gonna happen down here? Now, the next thing is what we can do is you can start to explain this with the concept of the collision theory. Now, when we have a smaller size of reactant, the surface area of the reactant is going to increase, which means that actually the frequency of the collision of the reactants will start to actually increase, or we can say reactant particles will start to increase. This is the point where you can try to implement the collision theory into. Now, when the frequency of collision of the reactant particles start to increase, then this leads to the frequency of the effective collision of these reactants particles. Okay, then they will increase as well. And then lastly, that's the reason why that gets us to the conclusion that we got from the beginning. The rate of reaction will start to increase. Now, what about the second one, the concentration? As for the concentration of the reactants, okay, now when the concentration of the reactants start to increase, okay, what is gonna happen? So the number of particles per unit volume increase, okay, per unit volume increase. In other words, well, we actually get more reactant particles, right? Okay, so per unit volume increase. Now that makes you will have what you will start to have more higher frequency of collision, and then after that you have a higher frequency of effective collision of the reacting particles. So in other words, that gives us a higher rate of reaction. Here's a gentle reminder, you can use this kind of a shortcut, and then this is not really something that is mathematical. In the real exam, we will still have to write the full name of this. Now, after that, okay, what else do we have? We also have a pressure of gas, which is what about pressure of gas? What is going to happen? Here's the interesting one. You see, the pressure of gas actually, the way that how it can be written is exactly the same as the concentration of the reactants, but that only applies to gas particles. So when the pressure of the gas increase, number of particles per unit volume is going to increase as well. So which is why the frequency of collision increase, that leads to the increase in frequency of effective collision. Hence, the rate of reaction is increasing. The only change that you need to make or to do is change the leading sentence, isn't it? Okay. Now the next one, the third one, which is temperature. As you have seen in the previous video, and then I had mentioned that, okay, the temperature actually represents the average kinetic energy of the particles, isn't it? So when the temperature increase, what is gonna happen? The average kinetic energy, okay, average kinetic energy of the particles, okay, is going to increase. When your particles are actually, the kinetic energy increase, then it means that your particle is going to move faster. When it moves faster, what is going to happen? The frequency of the collision starts to increase, and the frequency of effective collision is going to increase. Therefore, you will also have the increase in the rate of reaction. Lastly, which is our dear catalyst, the presence of the catalyst. See, in other words, when you have a catalyst presence, okay, what is it gonna do? It is going to actually provide an alternative pathway, for your reaction, okay? But this time, the alternative pathway actually has a lower activation energy. You may write a symbol like this one with the EA. Okay, it is going to provide an alternative pathway with lower activation energy. And what is it gonna happen? So this makes what? This makes, okay, more particles, okay, more reactant particles. Okay, more reactant particles can achieve, or you can say they can overcome the lower activation energy, or you can say the new activation energy. Okay, so what is it gonna happen? We will have actually more or higher frequency of effective collision. The frequency of collision is still going to remain the same, okay, but this time it's going to change only the frequency of effective collision. Now, that is the reason why the rate of reaction increase. As in overall, for the first three factors, they actually increase the rate of reaction because of the increase in frequency of collision leads to the increase in frequency of effective collision. Hence, the rate of reaction will increase in the end. However, the last factor, which is the presence of catalyst, only the frequency of effective collision increase, but the presence of catalyst doesn't actually change the frequency of collision. Therefore, in the end, still, okay, the rate of reaction increase. That's something that you might want to take note.